Imagine gazing upwards. The sky, once a vibrant tapestry of clouds, now stretches vast and empty, a blank canvas where once billowed fluffy cumulus and wispy cirrus. This is not a scene from science fiction, but a potential reality facing our planet. The disappearance of clouds, a seemingly innocuous event, could have catastrophic consequences for Earth's delicate climate balance. For millennia, clouds have played a pivotal role in regulating our planet's temperature. They are the Earth's sunshade, reflecting sunlight back into space and keeping our planet cool. But clouds are not merely passive players in the climate system. They are dynamic, complex entities, and their disappearance could unleash a cascade of unpredictable and potentially devastating consequences. Clouds are the visible manifestation of a continuous water cycle, a delicate dance between evaporation, condensation, and precipitation. They moderate Earth's temperature in two key ways. First, their bright surfaces reflect sunlight back into space, a phenomenon known as the albedo effect. This cooling effect is particularly pronounced with low, thick clouds like stratocumulus, which act like giant mirrors in the sky. However, clouds can also trap heat radiating from the Earth's surface, similar to the greenhouse effect. High-altitude cirrus clouds, composed of ice crystals, are particularly effective at trapping heat. This dual nature of clouds, both cooling and warming, makes their role in the climate system complex and fascinating. Scientists, using a combination of satellite observations and sophisticated climate models, have begun to observe a worrying trend. Clouds, particularly the low-lying reflective kind, are disappearing. This decline is most pronounced over the North Atlantic, a region crucial for regulating global ocean currents and climate patterns. While the exact extent of cloud loss is still being debated, the trend is undeniable and raises serious concerns about the future of our planet's climate. The reasons behind this vanishing act are complex and interlinked. Rising global temperatures, primarily driven by human emissions of greenhouse gases, are playing a significant role. As the oceans warm, they release more heat and moisture into the atmosphere, altering atmospheric circulation patterns and influencing cloud formation. Warmer ocean temperatures can create conditions that are less favorable for the formation of low-lying reflective clouds like stratocumulus. These clouds prefer stable, stratified air masses, but warmer oceans can inject more turbulence and convection into the lower atmosphere, disrupting cloud formation. This disruption of cloud patterns is just one example of the intricate and often unpredictable ways in which climate change can manifest. Ironically, efforts to reduce air pollution, while beneficial in many ways, may also be contributing to cloud loss. Sulfate aerosols released from industrial activities and ship exhaust can brighten clouds, making them more reflective. However, regulations aimed at curbing air pollution have led to a decline in sulfate aerosols, potentially diminishing the reflectivity of clouds and reducing their cooling effect. Section 5. A world without clouds, a hotter reality. The consequences of a cloudless or less cloudy world are alarming. Without the reflective shield of clouds, more sunlight would reach the Earth's surface, leading to accelerated warming. This warming would have far-reaching impacts on ecosystems, agriculture, and human societies. Sea levels would rise at an even faster rate, threatening coastal communities and infrastructure. Extreme weather events such as heat waves, droughts, and floods would become more frequent and intense, pushing already stressed ecosystems to the brink. The disappearance of clouds could also trigger dangerous feedback loops, accelerating the pace of climate change. For example, as the planet warms and ice sheets melt, the Earth's surface becomes less reflective, absorbing more heat. This further warming could lead to even more cloud loss, creating a vicious cycle of warming and cloud disappearance. Section 6. Echoes of a Warmer Past. The PETM Connection. The potential consequences of cloud loss are not merely theoretical. Scientists studying Earth's past have uncovered evidence of a period known as the Paleocene-Eocene thermal maximum, or PTM, which occurred about 56 million years ago. During the PETM, global temperatures spiked dramatically, with estimates suggesting an increase of 5 to 8 degrees Celsius, or 9 to 14 degrees Fahrenheit, in a relatively short period. While the exact causes of the PETM are still being investigated, some scientists believe that changes in cloud cover may have played a role. The PETM serves as a stark reminder that Earth's climate system is capable of dramatic and rapid shifts, and that the consequences of such shifts can be profound. Section 7. Navigating the Cloudy Future, Research and Action. The disappearance of clouds presents a formidable challenge, but it is not an insurmountable one. Scientists are working tirelessly to improve climate models, incorporating more sophisticated representations of cloud processes and feedback mechanisms. These improved models will provide a clearer understanding of the complex interplay between clouds and climate change, allowing us to make more informed decisions about mitigation and adaptation strategies. However, scientific research alone will not be enough. Addressing climate change requires a global effort to drastically reduce greenhouse gas emissions. Transitioning to clean energy sources, improving energy efficiency, and promoting sustainable land use practices are all essential steps in mitigating climate change and preventing the worst-case scenarios of cloud loss. Section 8. Our cloudy responsibility. The disappearance of clouds is a stark reminder of the interconnectedness of Earth's systems. It underscores the urgency of addressing climate change and the need for collective action. We cannot afford to take our planet's delicate climate balance for granted. The fate of our clouds, and indeed the fate of our planet, rests in our hands. Let us choose a path that ensures a future where the sky remains a canvas for the ever-changing beauty of clouds. By supporting policies that promote sustainability, reducing our own carbon footprints, and educating others about the importance of climate action, we can make a difference. The time to act is now, before the sky becomes an empty canvas, devoid of the clouds that have shaped our planet and inspired wonder for millennia.